Hello, and welcome back. In this demo, we will explore how to enhance selector reliability using the visual tree hierarchy and find children methods in UiPath Studio. Selectors play a crucial role in UiPath Studio, as they need to be specific yet flexible enough to handle dynamic changes in the user interface. The unified targeting method, part of the modern design experience, generally works well in most scenarios. However, there are rare cases where the visual tree hierarchy and find children methods can be very useful. By understanding and practicing these methods, you'll gain the ability to fine-tune selectors and handle unique situations that require more precision. So let's dive in and get started. We already have a simple workflow prepared for this demonstration. Its purpose is to highlight the first name text box on the RPA Challenge webpage. The robot will loop through the process of highlighting the text box and clicking the Submit button 5 times, keeping track of the count using the index variable. Additionally, we have 2 empty workflows, one for visual tree and another for find children. We will use these workflows to showcase each method and add the necessary activities accordingly. Now, let's focus on the visual tree hierarchy method. This approach involves analyzing the hierarchical structure of UI elements to fine-tune selectors by navigating through the visual structure of the UI to identify specific elements based on their relationships and positions. By understanding the relationships between elements and selecting appropriate attributes, a selector can be created that accurately identifies the desired element. This method provides greater control and precision in creating reliable selectors for automation workflows. To see it in action, let's open the visual tree hierarchy workflow. First, let's add a Use Application browser activity and configure it to open the RPA Challenge webpage. Next, add a highlight activity and indicate the first name input field. For this demonstration, assume that the input field does not have an attached label and the anchor element is not identified. To replicate this, let's remove the anchor element for this target. Furthermore, let's disable other targeting methods and focus solely on the strict selector. Now, let's edit the strict selector by accessing the UI Explorer. We can observe that the input field is located within the div container alongside the corresponding label. Upon examining the div container more closely, we discover that the first name label is present within the inner text attribute. This valuable information will allow us to construct a more reliable selector for our use case here. By leveraging the inner text of the container, we can effectively identify the input without relying on the name or ID. To make use of the label text information, we will modify our selector by including a div that contains the label text. In simpler terms, we will activate the parent node of the input field and use the inner text attribute to identify it within our selector. However, we have a problem with the CSS selector we're using. It relies on a specific way of finding elements on the web page, and if the web page's structure changes, the selector might not work anymore. To solve this problem, we'll remove the CSS selector from our script. This will make our script stronger and more adaptable, ensuring that it can find the right element even if the web page changes. Additionally, we notice the presence of a secondary container nested within the main container. Although it shares the same structure, it is not essential to our task. Therefore, we will proceed under the assumption that it is not important and can be safely ignored. Alright, with this approach, we hope we have updated the selector to accurately locate the desired input without relying on specific IDs or names. Let's validate the generated selector, and it looks good. So let's save and confirm our selection. Let's save the workflow. We'll navigate back to the main workflow where the visual tree method.xaml has already been invoked. It's time to run the project and witness our automation in action. Great, it works! This concludes the approach of enhancing the selector by configuring a better path in the UI tree. It's time to learn about the find children activity. As mentioned earlier, in some rare cases, the methods we discussed, such as using unified targets, adding more anchors, using wildcards, and utilizing the UI tree, may not be enough to meet our needs. In such situations, we can employ a more specific approach using the find children activity. The Find Children activity allows us to target a reliable container within the UI and retrieve all the child UI elements present within that container. This activity provides a way to gather a comprehensive list of elements that we can further analyze and interact with during our automation process. By using this method, we can navigate through the UI elements with confidence and locate the specific ones required for our task. When the standard methods fall short, the Find Children activity becomes a valuable tool for achieving a more precise and targeted selection of UI elements. It offers a reliable solution for situations where we need to explore the UI hierarchy in depth to locate the desired elements. We have already prepared the empty workflow for the Find Children activity. Now, let's open the findchildren.xaml workflow. The use case remains the same. However, we will now incorporate the Find Children activity to achieve our objective. Let's proceed by adding a Find Children activity to our workflow. Now, let's open the UI Explorer and click on Indicate Element. From there, we'll select the first name input field on the web page. Next, we'll select the div container that acts as the parent container for the desired UI element. From the right-hand side of the UI Explorer, we'll enable the inner text attribute. We'll validate our selection and then click on the Highlight button to observe that both the first name label and the first name text box are highlighted, indicating that our selector is correctly identifying these elements. Let's copy it for further use. Let's navigate back to UiPath Studio. In the Find Children activity, we will click on the Indicate on Screen button and select any element on the web page, such as the first name label. Please note that we don't need to choose a specific element. This step is just to replace the generated selector with the one we previously copied from the UI Explorer. As mentioned before, the Find Children activity outputs a collection of UI element children identified within the defined scope. To store this output, we will create a new variable called children. The Find Children activity outputs a collection of UI element children based on the chosen scope. Let's explore the scope options. 1. Find Children includes immediate children nested within the specified element. 2. Find Descendants. Expand the search to include all descendants, including nested elements. 3. Find Top Level. Considers only the direct child elements at the top level, excluding nested containers. 4. Find Process. Filters elements based on their data types for targeted operations. 5. Find Thread. Targets elements with default or fixed values for specific interactions. By selecting the appropriate scope, you can control which UI elements are included in the collection, allowing for more precise and specific automation tasks. In this case, we will change the scope to Find Descendants to include all descendants within the defined scope, expanding the search beyond immediate children. This allows us to retrieve all the child elements, including those nested deeper within the parent container. To store the output of the Find Children activity, we have the children variable, which is a collection of UI elements. To iterate through this collection, we'll use the ForEach activity. In the ForEach activity, we'll set the iterator as element with the type argument as UI element. The input variable for the ForEach loop will be the children collection. This will allow us to access each UI element within the collection and perform actions or operations as needed. Next, let's add a Use Application Browser activity to our workflow and configure it to target the RPA challenge page. Next, we'll add a Highlight activity. When configuring the Highlight activity, it's important to note that we won't be using a selector as our input. Instead, we'll use an element from the Children collection. Specifically, we'll reference an object of the UI element type using the element iterator. Keep in mind that for any UI automation activity, you can either fill in the selector property or the element property, but not both. It's a choice between using a selector to identify the element or referencing a specific element directly. Moving on, if we highlight all elements in the collection, we'll end up highlighting both the first name label and the text box. To solve this, we'll use an if activity to identify the input field. We'll add an if activity and set the expression as element.getFriendlyName.contains input. Next, we'll move the highlight activity inside the then block of the if activity. Finally, we'll save the project and run it from the main by invoking the workflow. Great! It works! This concludes the approach to use a Find Children activity to retrieve all the child UI elements of the specified container. With this, we have reached the end of this demo. To recap, when facing situations where reliably identifying a UI element is challenging, we discussed two advanced techniques: the visual tree method and the Find Children method. The visual tree method involves analyzing the target element and its parent nodes in UI Explorer to identify a combination of attributes that make the selector more reliable. On the other hand, the Find Children method allows us to select a stable container and retrieve its child UI elements as a collection. We can then iterate through the collection and filter for the specific element we need. It's important to note that UI automation activities can use either a string selector in the selector property or a UI element object in the element property, but not both, to identify a target. When encountering difficult situations, such as working with dynamic web pages where reliable selectors cannot be automatically identified, remember to consider these approaches and apply the most suitable one. Thank you for watching, and happy automation!